Hello, this video is to help you prepare for test one. So for test one, there are 20 questions, and these questions will be very similar to what you'll see on your actual test. All right, so it says estimate the x and y intercepts from the graph, but we can see that the graph is up here. And as far as my x-intercepts go, which I'm going to highlight in red for you, it's where it touches the x-axis, right? And there, it's not touching it at all. So this would be none. And then for our y-intercept, it would be where it's touching the y-axis, which I'm going to highlight in green for you. So we're really looking at where the blue and the green intersect, and that would be right there. And that ordered pair, which is asking you to write it as an ordered pair, would be 0, 3. All right, so let's move on to number 2. Number 2 is asking a similar question, but we have, of course, a different graph. And so I'm going to start with the x-intercepts, and I'm going to highlight them in red for you. So the x-intercept, actually, there's only one. And you can see by my graph is only crossing the x-axis. Remember, the x-axis goes from left to right at -3, 0. And then for my y-intercepts, it is in two places. So here's the y-axis, and that would be here and here. And so those ordered pairs are 0, -1, comma, 0, 2. So we do use an ordered pair, and we're going to separate our answer using commas. Okay, let's try number 3. So number 3 says, suppose that the relation H is defined as the following. And so we've got a list of ordered pairs. It's asking us to give the domain and range of H. And so this is a two-part question. So I'll start with the domain, and they are asking us to use set notation, which is totally fine. Now just remember, domain are your x values. So I'm going to highlight these for you in blue. So here are all my x values, of course, that's the x coordinate there. And whenever I write this, I'm going to have to list these values, and I'm going to be putting a comma in between. So I've got 7, -5, and +5. Now notice we have the number 7 twice, but I only list it once. Okay, so that's my domain. Now the range are my y values, and I'm going to list those, I'm going to highlight them first in red, and then I would list them a very similar way. So I'm going to have the set of, and I have 9, 1, 0, -5. All right, so all of my y values are listed. So that's my domain and range. Okay, number 4 says, find the x and y intercepts. Write each intercept as an ordered pair. If there's more than one, use the and button. All right, so now we're finding the x and y intercepts, but this time we're given an equation, right? So if you remember, to find the x-intercepts, the way we do that is we plug 0 in for y, and we solve for x. And I just want to point out, since we're plugging 0 in for y, we're going to have something comma 0, right? Because it's always x comma y is our ordered pair, and we're plugging 0 in for y. So I'm going to have -3x minus 6 times 0 equals 18. Keeping in mind that anything times 0 is just 0. So that part kind of goes away in a sense, because that would be 0. So then I really have -3x is equal to 18. Divide both sides by -3. I end up with -6. All right, so the ordered pair is -6, 0. Anytime you have an x-intercept, it's always going to be some number, 0. So please keep that in mind. Now for the y-intercept, you might remember that we do something similar, but instead we plug in 0 for x, and then we solve for y. And since we're plugging 0 in for x, we're going to have 0, something, right? Okay, so I have -3 times 0 minus 6y equals 18. anything times 0 is 0. So in a sense, that goes away. And I'm really just left with negative 6y is equal to 18, but it's negative 6 times y. So I divide both sides by negative 6, and I get y equals negative 3. And so my y-intercept is 0, comma, negative 3. Okay, let's move on. Now we're going to be determining if the relation defines y as a function of x. Remember that in order for something to be considered a function, for every x value, there can only be one y value. But another way to say it is that the x's cannot repeat, and graphically, it has to pass the vertical line test. All right, so I'm going to take a vertical line across and see, does this pass the vertical line test? Is it only crossing in one spot? And it is, so this would be a yes. Now let me explain when it would be a no. So I'm going to put not a function so you can see the difference, because you might get one that is not or one that is. And so I want to show you a counter example, right? So if I had a graph that looked like this would not be a function. It would fail the vertical line test because it would cross in more than one spot. Okay. Next, we have a mapping problem. It says determine if the relation defines y as a function of x, and this time we have mapping. And so this 3 is going to 2 and 8 and 9 and 6. So in this case, if I wanted to convert these to ordered pairs, I would have 3, 2, 3, 8, 3, 9, and 3, 6. Okay, that is not a function. The x's cannot repeat. There can only be one value of y for our x value. Now, an example of yes for mapping would be if I had something like this, and then this one was going to maybe a 7, and maybe this 2 is going to a 7, and then maybe this 5 is going to like a 10. But this would be considered a yes, because if I wrote it as an ordered pair, it'd be 1, 7, 2, 7, 5, 10. And so I don't have any x's going to more than one value. Okay, number 7 gets into some function notation. So now it says evaluate the function h of x is equal to 4x squared plus x for the given value of x and simplify your answer. So I'm going to find h at negative 4, and I'm going to plug negative 4 in wherever there is an x. And so h at negative 4 would equal 4 times negative 4 squared plus negative 4. All right, and then I'm either at this point using a calculator or I'm doing this by hand. Even if I was doing it by hand, I would use a calculator to check it. All right, because if you don't hug the negative 4 with parentheses, you may make a mistake in your calculator. All right, so I'm going to do this in my calculator. I'm going to show you what it would look like by hand as well. So when I do this in my calculator, I end up with 60. And when I do this by hand, I would do negative 4 squared first, which would be a positive 16 because a negative times negative is positive. And then I would do 4 times 16, which is 64, plus negative 4 is indeed 60. All right. Let's try question 8. Evaluate k at x is equal to x squared plus 2x for the given value of x and simplify your answer. Okay, so this one I can already tell. Oh man, I've got to put b minus 2 into these two places. This is going to take some simplifying for sure. So k at b minus 2 is going to look like this. So I'm replacing x with b minus 2. Okay, then I have to remember that b minus 2 squared is actually b minus 2 times b minus 2. So this is going to require some side work here. All right, and so whether you like to do the box or the FOIL method or just simply the distributive property where I'm going to multiply b by b, that would be b squared. I'll multiply b by negative 2, that's negative 2b. So that takes care of the b. And then I'll do the same thing with negative 2. I'll do negative 2 times b, which is negative 2b. And then negative 2 times negative 2 is positive 4. and then I combine here. Those are like terms. So negative 2b minus 2b is negative 4b. So b squared minus 4b plus 4. And then over here, I'm going to go ahead and distribute. Okay, so that's going to be plus 2b minus 4. And I'm going to drop that down. Woo. All right, so workout. Now we're almost done. We've got to combine our like terms though. So I have this negative 4b is going to go with positive 2b, and then my numbers are going to go together. So I'm just combining my like terms. So I have b squared, which doesn't go with anything. Negative 4b plus 2b is negative 2b. And then positive 4 minus 4 actually cancels out to 0. And so I'm just left with this b squared minus 2b. All right, let's move on to number 9. So number 9 says determine the domain and range of the function. Keeping in mind that the domain is from left to right because we're describing the x values and the x-axis goes from left to right. We are going to use interval notation. All right, so the farthest left here is negative 3. Notice it's an open circle, so I hope you remember that means parentheses, right? It's an open circle, that means parentheses. And then the farthest right, the farthest right is the fact that we have this arrow, right? So it's going to go all the way off the screen, all the way to eventually 5 and 100 and like 10 million. And so we describe that as infinity because it's going all the way to the right, all right? And keep in mind that infinity and negative infinity always gets a parentheses, all right? So for interval notation, that's going to be from negative 3 to infinity. Okay, now the range, because we're talking about the y-axis, we're talking about the bottom to the top. Okay, so I scan my graph. I'm gonna start way down here. I don't see it, I don't see it, I don't see it, I don't see it. When do I see my graph? Okay, I finally see it at 1, all right? And 1 is an ordered pair. There's an infinite amount of ordered pairs right here making up this line, right? So 1 is definitely included, and you will know it's not included because there would be like a giant hole, kind of like this one right here, right? So 1 is definitely included. So 1 is going to have a bracket, and then how high up does my graph go? Well, this arrow here is going up and to the right. So eventually it's going to hit up like 10 and 500 and eventually infinity. So it goes all the way to infinity. So 1 to infinity. All right, let's try another one that is quite similar. So you might want to like pause the video and try this and then you can check your answer. Let's see how you did. So our domain from left to right is going to be from negative 3 to infinity. And then our range is the bottom to the top. So it starts at negative 1 and it goes all the way to infinity. Okay, let's move on to number 11. So we're also doing the domain and range again, but this is a different type of function, right? It looks different. And so our goal is that you're able to find the domain and range of all different types of graphs. So for the domain, I'm going to go from left to right, and I want to point out that these arrows, they don't just go straight up like a football goal. They're actually going like more like this. I just want to point that out. Okay, so it does go all the way to the left, and it does go all the way to the right. So this would be from negative infinity to positive infinity. And then for our range, our lowest point on the graph does not start until 0, right? 0. That's our lowest part on the graph is 0. So it starts at 0, which is included because there isn't a hole in the graph, and it goes all the way up to infinity because of those arrows. So that domain would be from 0 to infinity. Okay, so from memory match the equation with this graph. So this is just part of 6.1 where you have a plethora of graphs that you should kind of have memorized, right? So 1 over x is actually this one. You might get 1 over x, or you might get x squared, or you might get the square root of x. And so it's important that you have those graphs memorized, or you maybe if you get to use a reference sheet, you write write them on your reference sheet. All right, number 13. We're going to use translations to graph the given function. So I have the square root of x plus 1. What does that do? Well, the plus 1 I know is what we call a vertical shift up 1. And in Alex, it should allow you to take this graph and literally just shift it up 1. Okay, and then it makes the new graph for you. Okay, so you really just need to know your different transformations and how to describe them so that you can actually apply them. Okay, number 14, we're going to have the absolute value of x minus 5. And we know that since it's inside the absolute value, it's like there's invisible parentheses in there. And so that would mean that it's horizontal. So I like to think of horizontal like the O is parentheses. And that always helps me to remember that if it's in parentheses, it's going to go left or right. Now, since it's negative, it's actually going to go to the right. So it's going to go to the right 5. So I know that the absolute value, based on my memory match, has a graph that kind of looks like this. But I'm going to actually move it to the right 5. And in Alex, I should be able to shift the graph to the right 5. All right, cool. Okay, let's try number 15. So similar idea, we're just using our translations to graph. So I have x cubed plus 3. I know that that is a vertical shift up 3. And so I'm going to take my graph and I want to move it up 3. And like I said, Alex should allow you to do that pretty easily as long as you have been doing your homework and you know how to use those graphing features in Alex. But really, it's not that bad. You just literally take the graph and shift it up. Okay, now we're going to get into some multiple transformations. So in this case, we have 2 transformations. This x plus 2 is like it's in parentheses. And so this is going to actually be horizontal shift to the left 2. And then if you remember, the minus 4 is going to shift it down 4. All right, so I'm going to take my tool in Alex. I would go to the left 2. So 1, 2. And I'll go down 4. 1, 2, 3, 4. And then it should draw that new graph for you. Okay, let's move on to number 17. 17 is some more of describing, but now we have it kind of all mixed together. And in Alex, they want you to go in a certain order when you describe it. Okay, so steps for graphing multiple transformations of functions. They want you to do the horizontal first, the horizontal shift, and then a horizontal and vertical stretch or shrink, reflects against the axes, and a vertical translation. Okay, so we have this function, and we're going to be doing a whole lot of stuff to this. All right, so let me rewrite this down here just so that I have more space. So I'm going to rewrite this for you. Okay. Now, I'm going to start with the parent function. So remember, to figure out the parent function, you can kind of just look at it and I can just say, okay, it's x squared. But really, if you're not sure, think about all the different transformations we have. And if we took them all away, like if I erased all these transformations, and I'm going to be a little dramatic and I'm going to do this in green. So if I took away this and I took away this and I took away this, well, what would I have left? Well, I would have x squared left. That's my parent function. Now let me undo that because that's messy. Okay, so my parent function is x squared. So it's going to ask me that. And then for the blanks, it's going to have these options down here that I get to pick from. So first, we're supposed to do a horizontal translation, which it's fine. That is to the right, 6.2. Okay, I know that's horizontal. So I'm going to say a shift, the graph of f, and then it's going to go to the right, 6.2. And you're not going to have to type this in. You're going to be selecting it, all right? I'm just writing it in because that's what it looks like on paper pencil. So we took care of 1. Now we're going to go to number 2, which says a horizontal and vertical stretch and shrink. Okay, so right here, that's what the 1/5 is doing. If you remember, we call that a vertical shrink because it's in between 0 and 1. So this will be a shrink of the graph, and it's going to be shrinking vertically by a factor of 1/5. Okay, remember, you're not going to have to write it. You're just going to select it. Now, there are no reflections across the X and Y axis. There is no negative in the very front, and there is not a negative in front of the X. So you don't have to worry about that one. And then last, it says, let's do the vertical translation or shift. So that would be this part right here. I'm going to highlight for that in blue. And that would go up 7.2 or shift up 7.2. So I would choose shift, the graph, and then up by 7.2. Okay, that one is all done. Let's move into this next question. So this one is now performing operations of functions and also being able to understand the graph. So this first letter, A, says find f at 1. Remember that that's basically saying when x is 1, what is y? And we're talking about the blue function because we're on f. Okay, so when x is 1, which is right here, what is my blue graph? Where is it located at for the y value? Okay, well, there's my ordered pair, and that's at 1. So this would be 1. Okay, so to find g at 0, we'll do the same thing. So when x is 0, what is y? Okay, so here's my x-axis, right? And I'm at 0. 0 is right here. But I'm looking at the red graph because it's the g. Okay, so I'm looking at the red graph. I go all the way up, and I notice that it's at 4. And so that would be 4. Okay, so this was 4, and then the previous one here was 1. All right, these are not that bad. That kind of looks scary, but it's not that bad. All right, now we're going to evaluate g minus h at 4. So this is just function operations, and you could be adding, you could be subtracting, you could be multiplying or dividing. So it's a random one, which one you're going to get. So g minus h at 4 is the same thing as g at 4 minus h at 4. All right, so I'm going to start with g at 4, which means I just need to plug 4 in for x there. Okay, so g at 4 is equal to the absolute value of 4 minus 4. Well, 4 minus 4 is 0, and the absolute value of 0 is 0. Okay, so this result is 0 minus, and now I need to find h at 4. So to find h at 4, I'm simply going to take 4 and plug it in right there. Right, let me do this with green. Okay, so that's going to be 1 over 4 minus 3. Well, 4 minus 3 is just 1. 1 over 1 is 1. So I end up with 0 minus 1, which is equal to negative 1. Okay, so if you just take your TLC, Tender Loving Care, on that problem, you should be fine. Just try to take your time because you're just evaluating the function and then performing the operation. Okay, last but not least is my favorite one, compositions. I wish we had like 100 of these on your test because I love compositions. So we're going to find the composition of f and h at negative 1. All right, so f and h at negative 1. And remember that, well, you can choose to write it with parentheses. I like to rewrite it as f at h at negative 1. That helps me to know where to start. I'm going to start at h at negative 1. So h at negative 1 is equal to, and I'm going to use the h function, so 7 times negative 1 plus 8. That would be negative 7 plus 8, which is positive 1. And that would go here. Okay, so h at negative 1, I got 1. So then I drop down, and now I need to find f at 1. So remember, I use this result here to evaluate f at 1. And so here's the f of x function. So that's going to be 1 cubed plus 6 times 1. Well, 1 cubed is just 1, plus 6 times 1 would be 1 plus 6, which is 7. So I end up with 7 for that one. And that was a whole lot of fun. I think that this is a really fun test. All right, I hope this video helps, and I hope you do well on your test. Bye.